Good afternoon, everybody. One of the later sessions in the day, so don't be falling asleep. So my name is Simon Todd. I'm a Senior SE Specialist for vSAN across EMEA, so I work for VMware. I'm going to be talking about, obviously there's been a number of vSAN sessions today, so I'm going to be talking about some customer success stories, as well as what we call lessons learned from the Battlefront, okay? So there's quite a few things in there that I'm going to be talking about as to, like for example, how customers have ran POCs and problems that they've ran into because of their whole misconception around things like SSDs and things like that as well. So, I know Sky don't exist in Denmark, but everybody's heard of Sky TV, I presume? Okay, I'm a Sky customer. I'm pretty sure Lee's a Sky customer. So Sky looked at vSAN because they needed to maintain competitiveness in the market that they're in. So in the UK, for example, we have Sky TV, BT TV, Talk TV, Virgin Media. So they don't have the monopoly that they had a good few years ago. So in order for them to maintain competitiveness, they had to reduce a lot of their costs and increase on agility. So vSAN now allows them to spin up developer environments within minutes rather than hours, days, or weeks. So because of that, their time to market is a lot faster, which means they can realize profits quicker. It means they can be more profitable. I just wonder why they keep pushing up the price. As a Sky customer, yes. But they also have, in the days of traditional storage, you'd go out to your storage array vendor and you'd say, okay, we need to refresh a storage array. We need a petabyte of storage. And the array vendor will rub their hands and they'll go, yeah, we'll give you an array with 4 petabyte. And you're like, but I only need 1 petabyte. Yeah, but you'll grow into it. But you have to pay for it now. You know? Well, we only want to pay for 1 petabyte. No, 4 petabyte and you've got to pay for that upfront. So there's a huge upfront cost. So for Sky, they developed a whole grow-as-you-go concept, okay? So they build a vSAN environment for what they need now, and as they need to, they expand the environment out. So they're now no longer buying storage that they may or may not grow into, but they can reduce their costs by buying what they need right now and expanding it. And Sky are always expanding their environments, okay? So they started off with a modest 40, 50 nodes originally, and they're approaching 250 nodes now. So what does Sky run on vSAN? So they run their generic production workloads, SQL, Exchange, all general production type workloads. But things like Sky On Demand. So 2 of my kids, 8-year-old and 6-year-old, will fight over the Sky remote, and they use On Demand. And if On Demand didn't work, my life would be hell, okay? So the whole On Demand streaming runs on vSAN. Video transcoding, so they've moved all of their video transcoding platforms over to vSAN because of the performance that vSAN delivers for them. Sky Q offering, okay, a complete 100% streaming service also runs on vSAN as well. And now they're also looking at the ultra-high definition streaming service running on vSAN All-Flash. So they adopted vSAN when vSAN was 5.5, so hybrid only. And now they're actually moving over to vSAN All-Flash. And they're constantly adding more and more capacity to their environment. So to them, all these services are business critical. Well, it is in my house, because if On Demand didn't work, I tell you, my life would be hell. Okay. Water utility company. So we've gone from a media company to a water utility company. So this water utility company was one of the first customers I went to see in the role that I do now. Okay. So I moved from GSS into the SE role. And the first thing these guys said to me was, we want you to be honest. So I come from GSS, so I'm an honest person, so we went through all of that. But usually it's the sales team demonstrating to a customer what their cost savings could be with vSAN. However, with this company, I walked in, they had a spreadsheet already demonstrating what their cost savings were going to be. I didn't need to tell them, they were telling me what they were going to save. So up to 74% cost saving on certain virtual machines. So between 66 and 74%, which is a huge cost saving for virtual machines. Procurement cycle. So they were running on converged infrastructure. So their whole procurement cycle was between 13 and 26 weeks, from order to equipment being on site. With vSAN, they now call up their reseller, and they say, right, here's the SKU, we need X amount of nodes, the equipment is on site in 7 days. Okay, so it's making them more agile. Spinning up a new environment now takes at most 2 hours from rec and stack, install ESXi, deploy vSAN, whereas it used to take 7 days minimum. Okay, their whole business driver about adopting vSAN is because their IT couldn't respond to the speed of the business. They've now moved their business, they've now become a lot more agile because their whole process has become a lot faster. The whole concept of upfront storage cost was causing projects to stall, which was a huge business risk for them. Because in the UK, a water utility company, if there's a leak on a road somewhere, that water utility company has a certain time frame to fix that leak, otherwise they get fined off the government. So one of the projects they wanted to run was an early warning system for leaks. But because of the huge upfront storage cost of converged infrastructure and, oh yes, you're going to be buying this amount of capacity when you only need this much, was causing these type of projects to stall. So that was a huge business risk to them. But one of the guys who I know this company very well. I used to be a customer of theirs until I don't live in that area anymore. But one of the guys there always talks to me about their billing cycle, their GIS application. So prior to it being virtualized, it used to take 23 hours to run. Then they virtualized it on converged infrastructure, and they got that down to 16 hours. So when they started building their vSAN environments out, they moved this whole GIS application onto vSAN. And this whole billing cycle for 7 million customers now takes 3 hours to complete. And they always talk to me about this story. Every time I see them, it's 3 hours. That's the first thing the guy says to me, 3 hours. You know. So what type of workloads do these guys run? Do I have it in the next slide? Yes, I do. Exchange, SQL, View, RDSH, Oracle Rec, and their GIS application. So full production workloads. These guys are now up at around 150 nodes with around about 5 petabyte of storage on vSAN. Sky are approaching around 12 petabytes worth of storage on vSAN now. And they're constantly adding more. It's the same with this company as well. They're constantly expanding their environment, and their use case for vSAN is, if we can virtualize it, it's going on vSAN. Okay? So again, business critical type workloads for both Sky and this company. So everybody must have heard of these guys. Domino's Pizza, yeah? Do they have Domino's Pizza in Denmark? Okay. So they have a global ordering system. So no matter where you are in the world, if they've got Domino's Pizza, you're ordering off the same platform whichever country you're in. So if you're in the US, it's the same ordering platform. If you're in the UK, it's the same ordering platform. And that whole ordering platform runs on vSAN. So again, it's a business critical workload running on vSAN, because if something went wrong, then nobody would be able to order any pizzas, which means they would be losing quite a lot of money. So for them, 40% cost savings, and again, easily increase capacity and performance without downtime. That's one of the advantages of vSAN. You can add more capacity. You can add more nodes to vSAN without having to take vSAN offline. And it's done instantly. So when you put new drives in or you add new hosts, it's adding that capacity into vSAN straight away. There's no rebuilds or anything like that. So that's a huge advantage to them. One of the other advantages is it's a generalist admin that can monitor and maintain vSAN. vSAN is, as Lee said in his session earlier, vSAN is always about simplicity, okay? And the saying is, if you know vSphere, then you know vSAN. So my 11-year-old son can set up a vSAN stretch cluster. That's how easy it is. OK, who's been on an A380? Lee's been on a few. OK, I can't name the airline because I haven't got their legal sign-off to name them right now. But it's an airline that has a large fleet of A380s. And these A380s are fitted with over 300,000 sensors. And these sensors are always constantly sending information back to a telemetric data analytics platform running on vSAN. So people are always asking me, big data on vSAN, how do people do it? This is a classic example of big data. They've got a large fleet of A380s, and when they're in the air, that's literally all their planes, 300,000 sensors from each plane sending information back to be analyzed. And the reason they do that is because when that plane lands at its destination, they've got an engineer ready to do any of the maintenance tasks that need to be done on that plane to get that plane turned around, because for every hour that plane's on the ground, it's $25,000. So that's one of the reasons why they do this, to be able to get that plane back in the air and earning money. So let's talk about some lessons learned. Okay, the next slide is one of Lee's. Okay, performance testing. Using the right tool in the right way matters. Yeah, I had a different slide, but Lee decided to, no, well, I've got a better one for that. So myself and Lee have been involved in a number of customer scenarios where they're doing a POC and they're doing performance testing. Okay, and literally the caption at the bottom. I'm running a POC, but I'm not getting the performance I expected from vSAN. I'm getting around 3,000 IOPS. And you can see there, 2,300 IOPS. And this is all flash. And you think, what the hell's going on? Okay. So when we had a call with the customer, not only did I have to educate them on how to use IO meter properly, because IO meter isn't virtualization aware, you have to understand what numbers you need to put into IO meter to be able to drive the IO. But there is also some configuration things that I'll be talking about a little bit later on as well. So on the performance testing, if you really must use IO meter, the first thing is, this was what their settings were. So they had one disk, and their outstanding IO was set to 1. That's not how SSDs work. That may have worked for spinning disks, but it doesn't work for SSDs. Okay? Because when manufacturers publish the statistics for SSDs, they're basing it on a certain block size and an amount of queue depth. Okay? So one outstanding I/O isn't going to fill up the... I refer to the queues as lanes on an SSD. So you've got one outstanding I/O, you're only going to use one lane, which is not going to deliver the performance. So in this scenario, if I still chose a single disk on the VM, but I increased my outstanding IOs to 64, guess what? I now get 35,000 IOPS, because I'm now saturating those lanes on the SSDs. So I'm now doing what the manufacturer gets their optimal results from. And if I go even further, and now I now have 10 disks on the VM, and each disk has an outstanding IO of 16, I'm now driving nearly 80,000 IOPS from a single VM. So it was me educating their performance testing team. If you really want to use a legacy tool like IO meter, you've got to put the right values in order to get the performance. You know, just testing it as you used to test a spinning disk isn't the way you can test it on SSDs. It just doesn't work like that. And remember, vSAN, whether you're using hybrid or whether you're using all flash, you've got a caching tier that's built of SSDs. And utilizing those SSDs is how to drive the performance. A single outstanding I/O just is not going to work. It's not going to perform. So I recommend for customers doing performance testing is use the proactive tests in the UI. Okay? Now, I've been out to customers where we've ran the proactive tests, and the first thing they say is, yeah, but that's a VMware test. How do we know you're not just manipulating the numbers? I went, okay, go and deploy HCI Bench. Yes, it's a VMware appliance, but it uses Oracle's VD Bench, which is a independent benchmark tool. And when they did that, they got exactly the same results that the proactive storage tests do. And I said, well, the proactive storage tests are a simple way of doing it. You go into the UI, you say proactive storage test, you choose the profile of what type of I/O you want, and also the storage policy that you want to run it against. And it just goes away, deploys the disks, does the test, come back, and you can see the performance results. HCI Bench is a really useful tool as well. It's an appliance. You configure the appliance to deploy out virtual machines. The virtual machines will deploy out. They'll do the performance testing. HCI Bench will then collect all the performance results as well as vSAN Observer results, so you can have a look at them in a bit more detail. If you really must use I/O meter, remember the number of workers and the outstanding I/O. That's what's going to give you the performance. So as I said, SSD performance ratings are based on an optimal I/O configuration. So read IOPS, in the example that this customer was using, their read IOPS were based on 66,000 IOPS, and their write IOPS was 62,000 IOPS per SSD. So if you did one outstanding I/O, their performance results are based on a queue depth of 16, so 16 lanes. If you do one outstanding I/O, you're only going to get a 16th of the performance of those drives. So that's just the way to manipulate I/O meter to get the most out of your SSDs. Who's familiar with this? You call up support. Your hardware isn't certified. You're not using the correct driver. You're not using the correct firmware. I come from GSS. I know I've delivered those messages in the past. But it's becoming more and more common because we do have a strict HCL because we're a storage vendor. We need to ensure that data is consistent and data is protected, because at the end of the day, if data loss happens or data corruption happens, who are you going to call? And it's not Ghostbusters, it's VMware. I was waiting for somebody to shout Ghostbusters, So again, the HCL is there for a reason, because this is hardware that's been certified for vSAN. We currently test all the controllers. Obviously, we're going to try and push that back more towards the vendors now, but the spinning disks and the SSDs are certified by the vendors to be used with vSAN. So at least if you know they're certified, you know they're going to work with vSAN. vSAN ready nodes. It's a really important thing to consider. Build your own versus vSAN ready nodes. Build your own, you have to manually go and check the HCL and check to see if those components are on the HCL. Whereas if it's a vSAN ready node, these are pre-certified configurations by the vendors that you know that all those components in those nodes are going to be vSAN certified. And those ready node configurations are customizable. For example, All Flash 8 has 384 gig of RAM, 1.2 terabyte SSDs, 14 core processors. But you might think, well, actually, I want 22 core processors. I want a terabyte of RAM, and I want 3.84 terabyte SSDs. You can do that. You can go to the vendor and say, I want this vSAN ready node, but I want to make these changes. And that's perfectly acceptable. Customers ask me a lot of the time as well about, obviously, things like VxRail, the hyperconverged appliance approach, versus vSAN ready nodes. And I always say to them, well, VxRail's good if you want the simplicity, but vSAN ready nodes is better if you want customization. For example, VxRail appliances come fully populated. So if you want more storage, you have to add more VxRail appliances. With vSAN ready nodes, you can customize them so you're not using all the slots. You've got bigger SSDs, so that if you need to expand them in the future, you just put more drives in. So it reduces the cost for customers as well to do it that way. There are multiple vendors. Even Intel now manufacture vSAN ready nodes. Okay, so we've partnered with all the major OEM vendors. So it's like, for example, this month, the flavor of the month might be Dell. Next month, you might fall out with Dell and you decide to go with HP. Providing your nodes of similar performance and of uniform capacity, same size drives, you can mix different vendors within the same cluster. And Dell announced with VxRail, because VxRail was based on Quanta hardware, they're now moving it over to Dell hardware, that they will support mixing Quanta-based hardware and Dell hardware within the same VxRail cluster. So we're not limiting you to sticking to one particular vendor within a cluster. One of the other things when we were talking about performance is when myself and Lee were on the call with this customer and the customer was running through their specification, they were saying, well, yeah, in our host, we've got one cache device and one capacity device. That just doesn't work. You know, it doesn't deliver the performance because you're hitting one drive, okay? Even if you're reading data, you're hitting one drive. So when I demonstrated that to them, I took half of my cluster away, created a 3-node cluster, and I created this group of one cache device and one capacity device. And I ran the same performance test, and I proved to them that it didn't work. So 2 disk groups per host is going to deliver a lot better performance than 1 disk group per host, because you've now got 2 cache devices. Rather than 1 cache device sitting on a 12 gig lane, you've now got 2 cache devices with its own 12 gig lane, with its own I/O queue and things like that. Multiple capacity devices per disk group. 1 just doesn't work. You want to try and have, especially if you're using dedupe compression, try and populate those disk groups out so that it's maximum that you can. We've also had a customer that, that ran a POC on hardware X, and they went into production with hardware Y. Hardware Y was a lower specification than their POC. And guess what? They logged a support call with, it's not performing very well. It's not performing the same way that our POC cluster did. Well, tell us about your configuration. Well, in the POC, we had Nexus 5Ks, we had this specification. What's production? Arista switches with this specification. We're like, but that's a much lower specification. You know, you're not going to get the same you're not going to get the same performance. So don't do a POC on ultimately powerful hardware and then go into production with lower hardware, because it's not going to do the job you intend. HCL, driver and firmware combination. There's a reason why the HCL has driver X and firmware X, because that's what vendors have certified. You can't use an older driver with a newer firmware, for example. That's not what was certified, and both the vendor and VMware will say that's not a supported configuration. So from a controller perspective, it's a driver and firmware combination. From a disk or SSD perspective, it's the minimum firmware on the HCL. So even though vendors produce newer firmware for the disks, that's fine. But the controller, you have to wait for them to certify the driver and firmware combination. Networking, MTU size. So we had a customer there that was doing a stretch cluster, and they were doing a POC on the stretch cluster, and they were using a temporary link they currently use for replication. And their link limit was something like 1430 MTU. Doesn't work. What's the default configuration of a vSwitch? What's your MTU size? Anybody? 1500. vSAN won't support anything less than that. Okay? So it was causing problems for them because they wanted to do this POC, but their MTU size was restricting the performance, and it just didn't perform very well at all. This wasn't going to be their permanent link. Their permanent link was going to have an MTU size of something like 10,000. So, but again, it was their link was causing the problem. If you've got multiple vSAN clusters, the recommendation is to create multiple multicast addresses. Okay? If you've got multiple clusters and they're all using the same multicast address, you're going to end up with a lot of chatter over multicast between all the clusters that isn't necessary. So creating a multicast address for each cluster is the best way to go. 10 gig Ethernet is a strict minimum requirement for all flash, and Lee called that out earlier on as well. Obviously with hybrid, depending on the workload types, we said we'd support 1 gig. Even with Robo, we supported 1 gig. Okay? Can't stress enough on that one because the whole point of Flash here is performance. And you're not going to be able to drive performance through a 1 gig network with Flash. So when you apply a vSAN license into your cluster, one of the things that it gives you access to is VDS for that cluster. Because we recognize the fact that 10 gig NICs and 10 gig switches are more expensive. You're going to have fewer of them in the server. So you're going to want to share those NICs with multiple traffic types. So we want you to use network I/O control, and that's only available with VDS. So irrelevant of your vCenter version, you could be running vCenter Essentials. You don't get access to VDS, right? But the moment you apply a vSAN license to your vSAN cluster, you can create a VDS for your vSAN cluster. It gives you access to that. You see, well, if you were in the session before, vSAN Beta, the 6.5 U1 beta, the encryption, the features for the stretch cluster, as well as the enhanced network and storage monitoring as well. I would have been able to do a live demo if I had my laptop up here, but I would have been able to show you some of the features. But vSAN is all about simplicity. I'm gonna throw a question out there. I'll just pick a victim. If you've got a 4 terabyte volume and you're down to 100 gig free, and your boss comes along to you and says, well, what's consuming the space? What could you tell him? Virtual machines? You couldn't give him any granular detail, okay? But since 6.2, we now give you the granular detail. So when you go into capacity reporting, we tell you this amount is being consumed by virtual disks, this amount is being consumed by swap files, this amount is being consumed by other files, dedupe and compression overhead, checksum, performance metrics. We break it down and give you that granularity of detail. There's also the health tools as well. So the health tools are really powerful to self-help. Something goes wrong in vSAN, it's there in the health tools. The health tools will tell you. You can expand it out and click on Ask VMware, and it will take you to a KB article telling you how to fix the issue. But there's also the performance monitoring as well. So this is all baked into the UI. The performance monitoring statistics aren't stored in vCenter. They're stored on the vSAN data store as an object. So your vCenter server can die a horrible death, and you have to create a new vCenter server. When you create your vSAN cluster and you add your hosts into that vSAN cluster, everything on vSAN is still running, and all the historical performance data is also still there because it's there stored as an object on vSAN. But we give you a lot of granularity, and I'm pushing more and more customers now to use this, especially in their POCs, because the granularity of the performance metrics is cluster level, virtual machine level, virtual machine disk level, ESX host level, disk group level, disk level. We give you all the granular information, even things like read cache hit rate in hybrid, or write buffer percentage used in all flash, D-stage rates, resync rates, things like that. It's all contained in those performance metrics. Storage hubs, Lee mentioned it in the session earlier. There's a lot of information on there. There's a lot of white papers and things like that as well. That's it. I've done in 35 minutes. Thank you very much, guys.